Ladies and gentlemen, I want us to look at this question, and the question is, find the equation of the tangent to the curve. Find the equation of the tangent to the curve, y equals to, that is x squared plus 1, close the bracket, into x minus 2, when x equals to 2. That is, find the equation of the tangent to the curve. Now, the equation of the equation of the curve is this. Now, since this is the equation of the curve, the first step that we shall take is to expand this so that we obtain, that is, y equals to, because if we cannot expand this, it will be difficult for us to differentiate. It will be difficult for us to differentiate. Therefore, we must expand this expression so that we can easily differentiate, because we can't differentiate when it is in this form. We can't differentiate. That is why we need to, that is, expand this so that we can differentiate it well to obtain the gradient function. Now, let us expand this. In expansion, we just take this and we multiply with the whole of this. That is x squared times x, it will be x cubed. Then x squared times negative 2, it will be negative 2x squared. Then positive 1 times the whole of this. So it will be positive 1 times x, it will be positive x. Then positive 1 times negative 2, it will be negative 2. Now, having that, then we can now obtain the gradient function of the curve. We can obtain the gradient function of the curve. Now, the gradient function of the curve is, that is dy over dx, which is, we differentiate each term in turn because this is a polynomial. So this one is x cubed. So if we differentiate it, we shall bring this 3 here, so that it will be 3x raised to this 3. Then we less that power, which is 3 by 1. Then minus this minus, we bring this 2 here, so that it will be 2 times, that is the whole of this, that is 2x raised to 2, then we less it by 1, that is the power by 1. Then plus the power of x here is 1. So we bring that 1 times the whole of this, that is x raised to 1, then we less that power by 1. Now, if we differentiate a constant, as I always say, that if you differentiate a constant, you will obtain 0. Now, this one will be, that is 3x raised to 3 minus 1 is 2. Then minus this minus, this is 2x raised to 2 minus 1. 2 minus 1 is 1. Therefore, this is 2x raised to 1, which is 2x. 2x times 2 is 4x. Then this one is x raised to 1 minus 1 is 0. X raised to 0 is 1 times 1 is 1. Therefore, this is the gradient function that we have. Now, let us have a look at our question. That find the equation of the tangent to the curve y equals to the whole of this when x equals to 2. That is, when x equals to 2. Now, we need to obtain the gradient. That is, when x equals to 2. Now, dy, that is over dx, equals to, when x is 2, that is, when x is 2, we can say that when that is x equals to 2, that is dy over dx will be, that is 3 into 2 squared minus 4 into 2, then plus 1. then plus 1. And in this case, we shall obtain our dy over dx as this is 2 raised to 2. 2 raised to 2 is 4 times 3 is 12. Then minus 4 times 2 is 8. Then plus 1. And in this case, we have 12 minus 8 is 4. 4 plus 1 is 5. And therefore, the gradient of the curve is 5 when x equals to 2. When x equals to 2. Now, let us go back to our question. Our question is, that is, we need to find the equation of the tangent to the curve, to this curve, when x equals to 2. Now, we don't have the coordinates. We don't have the coordinates where, that is, where the line where the tangent touches the curve. We don't have the coordinate where, that is, the tangent touches the curve. Therefore, we need to obtain the coordinates. Because we only have the value of x, we need to obtain the value of y by substituting in this original equation. By substituting in this original equation, so that we obtain the coordinates where the equation of the tangent meets, that is not the equation, but that is the line of the tangent meets with the curve. The line of the tangent meets with the curve. So we need to obtain the coordinates of the point where the tangent meets with the curve. That is the equation of the tangent, not the equation, but the line of the tangent meets with the curve. By obtaining the value of y, because we already have the value of x, and the coordinates are always in the form of x, comma y. Therefore, we only have the value of x, we need to obtain the value of y. Now, we have our y as that is x. Instead of x, we shall substitute with these 2. So we shall have, that is 2 squared, then plus this one. Then we close the bracket, we open 2 minus 2. And in this case, we have, that is our y equals to, this is 2 squared, which is 4 plus 1. Then we have 2 minus 2 is 0. So this is 4 plus 1 is 5. 5 times 0 is 0. This implies that our y is 0. Now, the point where that is the line touches the curve, because that is the tangent is a line. It is a straight line that touches the curve at a certain point. Now, the point will now be, that is our value of x is 2. Therefore, we shall have 2, 0, because the value of y is 0. Now, this is the point where the line touches the curve, because a tangent is a line that touches the curve. It is a straight line. Now, since we have the coordinates, and we have said that the gradient of the curve is 5, we have obtained 5 as the gradient of the curve, and we have said also that our m1 is just the same as m2, which is 5, because this is the gradient of, that is the curve, and this is the gradient of the tangent, and they are all equal. Now, since they are equal, our gradient of, that is our gradient of the tangent is 5. Now, since the gradient of the tangent is 5, and we have the coordinates, that is 2, 0, and this one is an equation of a straight line, because it is a line that touches the curve. The tangent is always a line that touches the curve, and it is a straight line. Now, in this case, we shall just take, that is the coordinates 2, 0, and the general points x, y, and the gradient, which is 5. Then we proceed to find the equation. Now, we shall have, that is the change in y over the change in x equals to the gradient, which is 5, because the gradient is always change in y over change in x. Now, given that is 2 points, this is the first point, this is the second point, and we have the gradient, the gradient of the line, the straight line, will be the change in y over the change in x. And this is what we have. Now, then we have to cross multiply. We have to cross multiply. We have to cross multiply. So that we have, that is 1 times, that is y minus 0, equals to, that is 5 times x minus 2. Now in this case, 1 times y minus 0 is just y, equals to 5 times x is 5x. Then 5 times negative 2 is negative 10. And therefore, we have obtained the equation of the tangent to a curve. The equation of the tangent to a curve, which is y equals to 5x minus 10. Y equals to 5x minus 10. 5, that is y equals to 5x minus 10. That is the equation of the tangent to this curve that we have when x equals to 2.